In this section, we're going to be looking at points, lines, and planes. So first, we're going to learn some key concepts about these three things. A point indicates a location and it has no size. So basically, a picture of a point would look something like this. A point, and usually you label them with a letter. Next, a line is represented by a straight path that extends in two opposite directions without end and has no thickness. A line contains infinitely many points. So let's look at what this would look like. Here you can see we have a line. It extends in opposite directions, and this is an example of just 2 points on a line. We have point A and point B. Now we're going to look at a plane. A plane is represented by a flat surface that extends without end and has no thickness. A plane contains infinitely many lines. So this is what a plane would look like. And these are just a couple possible points you can have on a plane. Those are points A, B, and C. Now we're going to look at collinear points. Points that lie on the same line are collinear points. So we're going to look at an example of this. Let's say we have a line. So you can see the line that's inside this plane has points on it. As long as the line inside the plane has more than one point, these points A and B are collinear points. Now we're going to look at the term coplanar. Points and lines that lie in the same plane are coplanar. So here you can see that we have a plane, and you can see that there's a line there, and there are points, and there's now two lines that lie in the same plane. So those lines and points are coplanar because they lie in the same plane. Now we're going to look at a couple more concepts. We have a segment. A segment is a part of a line that consists of two endpoints and all points between them. So a segment would look like this. We got point A and point B. There are no arrows at the end because it's a segment. It has a definite end and start point. Now we're going to look at array. Array is a part of a line that consists of one endpoint and all the points of the line on one side of the endpoint. So now we're going to look at what an array would look like. Here you can see that the ray has the arrow going in one direction, and there are 2 points on it, an endpoint and a point on the ray. Now we're going to look at opposite rays. This is two rays that share the same endpoint and form a line. So here we've got a ray. They got arrows going opposite directions. And then we have points AB and AC. But here, there's one ray is going to be ray AC, which is going left, and then ray CB is going right, and they both share the endpoint of C. Now we're going to look at a postulate when it comes to dealing with points, lines, and planes. A postulate is an accepted statement of fact. So let's look at the first one. Through any 2 points, there is exactly one line. So let's say we had points A and B, and we were to connect them with a line. And as you can see, line T passes through points A and B. Line T is the only line that passes through both points. Now we're going to look at another postulate. When you have 2 or more geometric figures, their intersection is the set of points the figures have in common. So let's break this down. So here we have 2 distinct lines. We can see that they intersect. We have line AE and line DB. And we can see that they intersect at point C. And we can state that they intersect at point C because that is the one point they both have in common. Now we're going to look at another postulate. If 2 distinct planes intersect, they intersect in exactly one line. So here we have plane RST and plane WST. Here you can see that one plane is lying flat and the other plane is lying perpendicular to the first plane. So the area where they intersect is actually going to be a line, and that's going to be line ST because there are 2 dots on that line, S and T. And that line is on both planes, plane RST and WST. Now we're going to look at a final postulate. Through any three non-collinear points, there's exactly one plane. So let's say we had three non-collinear points inside a plane. There is no straight line that can connect these three non-collinear points, but they can still be contained on one single plane. And that means that any three non-collinear points, there's exactly one plane, so points Q, R, and S are non-collinear, and plane P is the only plane that contains them.